is the first problem of today's Codechef Starters. And in this problem, we are given that there is a very caring mother who has n cookie jars with her, and each jar contains a different type of cookie. So there are AI cookies in the ith jar, and the mother wants to give some cookies to her K children. And she decides that she's only going to distribute a single type. That is, she'll distribute, like she'll first choose one of the n jars, and then she's going to distribute the cookies within it. So she'd like to ensure a couple of things. Each child should receive at least one cookie, and each child should also receive, and like every child should receive an equal number of cookies. So we have to find the minimum number of wasted cookies. So wasted cookies is nothing but the number of cookies that are left out from the jar which she had chosen to distribute cookies. So there are n jars. Each has some cookies, let's say. And let's say there are k is equals to 6. So she has 6. Let's say this is, so she has 6 children. So if she chooses this thing, then she cannot distribute even single cookie, right? If she chooses this jar, so she'll be able to distribute, every child of her will get 2 cookies. So there are 6 children. So 12 cookies are distributed, but 4 cookies will be left out. And here, just one cookie will be left out because there are 6 children and each will get 1. So this is the minimum number of cookies that are wasted. So how to find this? Just ignore these values, like jars which have number of cookies less than k. Otherwise, your answer will be, for all other jars, your answer will be minimum of your answer, whatever your answer is up till now. You can start with something very big like 10 to the power 9, and the number of cookies in the jar. What should I do? I should take modulo under k. Like how many cookies are left when you divide the number of cookies with k. And finally, this is your answer. Is it clear? Yes, no. Okay, what about others? Is it clear? Like if even someone has a little bit of doubt, like there are some students from level 2 or level 1 also. So like if you have any doubt, you can ask me. Don't worry about, like, if you have a silly doubt. So okay, everything is clear to everyone. So let me show you the implementation. So this is the implementation. In this, minimum is the answer for every cookie from 1 to n. You first take x as input. X is nothing but the number of cookies in this jar. So if x divided by k is more than 0, then only you should consider taking that jar. Like then only she would consider choosing that jar, because if x divided by k, like x, like in that case when x divided by k is less than, not less than, but it's equals to 0, then every child of her will get 0 cookies. So that's why you need to check this, and then you need to find what is waste. So waste is either this thing, or you can write it like simply like I said, x modulo k also, but both things are same. And finally, your answer is minimum of answer and the number of wasted queries. If answer is equals to long maximum, which was initially like something very big that you had initialized with, then in that case, the answer doesn't exist and you can print -1. Otherwise, you can print your minimum value. Is it clear? Yes, no, anything? Okay, let's go to next problem. Just give me a second. Okay, the which screen is visible? This. So this is the next problem, and in this problem we're given that a beautiful string, a string is called beautiful if all its characters are same. So these are the examples of beautiful strings, and these strings are not beautiful. Why? Because see, this string has both characters A, B, and this string has three different characters. So that's why these are not beautiful. Now we are given a string S of length n consisting of lowercase English letters, and we are also given queue updates, like queue update queries to be performed on S. Now in each update, we need to add a single character at the end of string S. And after each update, and also before any update is performed, we need to find the longest length, like what is the length of the longest beautiful substring of S. So first of all, one thing that needs to be cleared out, that what is a substring? If let's say this is the string, when we are required to find the longest, like the length of the longest if we are required to do this, then the string needs to be continuous. It's substring, not subsequence. So substring by substring, it means that it has to be continuous. So forget about update queries. First of all, how to solve this if we don't have updates? So in that case, if you're given the original string, when you're iterating from left to right, after you get a new character, if that character is equals to this character, like let's say if this character is equals to the last character, if let's say I had A here and I have A here. So up till here, I can maintain a count, whatever it is, and I can increase it by 1 here. And if let's say I would have received B and that is not equals to the last character, then I can make my counter equals to 1 again. So this way, at each instance, I will have the maximum length of substring that can end here, beautiful substring that can end at this position. And what I'll do at each index, I'll do answer is maximum of answer, comma, this count. So this will give me the answer or the length of the longest beautiful substring for this original string. Is anyone having any doubt in this? Yes, no. Okay, no doubt. So this is okay, but what if we have queries? So we are given like queries like add A to this, B to this, C to this. So this is same as what we were doing earlier. We have answer if this character is equals to the last character, add your count will become plus plus, otherwise your count will become 1. And you'll do the same thing for all the queue updates. And every time print this answer. So this is same as like adding character is same as iterating through this string. Like, is it clear? Yes, no. Update your answer. Is it clear? Okay. What about others? Okay. So let's look at the implementation. So this is the implementation. In this, I have first taken N and Q as input. Then I have taken the original string S as input. After that, what is the last character? The last character is this thing, S of N minus 1. Like this last will actually be used here. So when I'm performing the queries, right? But for the original string, what we can do, we have this count. If si is equals to the last is this temp. So if this is equals to this, your count will get increased by 1 and you can take this thing. Otherwise, your count will become 1. If this is not equals to the last character, like temp is already always made to be equals to the previous character. Finally, this is the answer before you have processed any query. And once you start processing queries, you have to do the same thing. Take the character as input. Check if this character is equals to the last character. If it is, increase your count by 1. Otherwise, make your count equals to 1. Finally, update your last character. Take your maximum, like answer will be maximum of answer, whatever your answer is up till now, or count. Finally, print your answer. So I hope this is clear to everyone. Is it clear? Yes, no, anything? Okay. So let's go to the next problem. So in this problem, we are given that given integers n and k, we need to construct a permutation p1 to pn of integers 1 to n such that there are exactly k indices I is between 1 and n, for which pi plus 1 is odd. Now, okay, I'll discuss this in a moment. But we need to like, okay, this is also okay. I'll just explain it here. Okay. Okay. First of all, a permutation is nothing but a permutation is arrangement of numbers from 1 to n in any order. Every number should occur exactly once from 1 to n. Now, what we have to do, we have to arrange these numbers from 1 to n such that there are exactly k pairs of pi where pi plus 1 is odd and k is between 1 and n minus 1. So actually this is a very simple problem because this is a plain constructive problem. How? See, let's say you have coupled all your odd here and all your even here. And by the way, your sum can be odd only when one of them is odd and one of them is even. If both are odd or both are even, the sum will always be even. So if you have coupled all your odd and all your even, then what is the number of positions at which you are getting pi plus 1 is odd? You're getting exactly one position, right? Yes, no. And if you do odd, even, odd, even, odd, even like this, you'll get exactly n minus 1 places for which pi plus 1 is odd. So everything in between is actually achievable. How? What you can do, first try to do odd even, like you do this once, you get one pair, then you do odd, you get two, you do even, you get three pair, right? Keep doing this until you have exactly k minus 1 pairs. And once you get k minus 1 pairs, just see if this is last one was odd, then first keep all odds and then keep remaining evens. So why, like up till here it was k minus 1, here you'll get one more, so it is like one more pair you'll get here. So then this becomes k. Now you might think like, what if k is 1? Then it's also okay. If k is 1, so at start only you have achieved k minus 1 number of pairs, that is 0 pairs. So start with odd, just keep all odds, and after it keep all evens. You'll get one pair. If you have to create two pairs, then first keep odd, then keep even. You get one pair, which is equals to k minus 1. Then keep all even, and then keep remaining odd. Is it clear? This will always ensure that you will get a valid permutation, because I have explained both the cases. In start, if you do like 1 is also achievable, k minus 1 is also achievable, n minus 1 is also achievable. Is it clear? This is one of the ways to do this. Okay, so let me show you the implementation. So in this, First, I have created two vectors, odd and even. Odd numbers are pushed in odd, even numbers are pushed in even vector. So start printing odd numbers, like we start from odd numbers. So odd is printed, first number in odd is printed. Then while the number of pairs is less than k minus 1, what do we do? For each time we check what was the last. If x is 1, it means the last was odd, otherwise the last was even. So first check if x is 1. If x is 1, then okay, if x is 1, then it means that you need to print odd, otherwise you need to print even, because we are changing x here. This is just making x from 0, it's making it 1, and from 1 it will make it 0. So print odd and remove the last. This is pop back, by the way, and this is push back. This is push back, this is pop back. Pop back just removes the last element from vector. Push back just inserts this ith element at the end of the vector. So we print odd, otherwise if x is 0, we print even. So this is done while like the number of pairs that we have pi plus 1 parity as odd is less than k minus 1. Once it becomes equals to k minus 1, we need to check what was the last. If the last was 1, like if x is 1, it means that the last element that was pushed or that was printed is odd. So if the last element was odd, what do you think should be the next? Like the next element should be odd only, right? Like I have explained here. If after some time we have done something like odd, even, odd, and we have got 1, 2, 3, 4. We have got 4%, 4 is equals to k minus 1. So you should continue with odd and then keep remaining evens, right? Otherwise, if you ended with even, you should continue with even and then print remaining odds. So this can be checked with the help of that x only. If x is, if not x means that x is 0. If x is 0, that means last printed was this thing, even. If even was the last printed, then you should print even only and then print remaining odds. So in that case, you can swap these two vectors and this remains same. Otherwise, you could have just like done this in two ifs. Like instead of swapping these, in first if you could have printed in this order, and in else part you could have swapped, like you could have first printed even and then printed odd. So this is one of the ways to solve this. Is it clear? Yes, no? What about others? Like I'm seeing only 3, 4 people. What about others? Is it clear? Yes, no? If you have any doubt, you can ask me. Okay, clear. Clear. Okay. So let's go to the next problem. So in the next problem, we're given that we have an integer x and we need to answer q queries of the following form. Given an integer p, count the number of positive integers y such that GCD of GCD of x and y to the power p is equals to LCM of xy. Okay, and we need to print answer modulo 10 to the power 9 plus 7. So if we look at x is between 1 and 10 to the power 9, there are 10 to the power 3 test cases. Q is between, number of queries is between 1 and 200, and pi is between 1 and 10 to the power 9. So basically what we have to do, let me show you here. So we are given an integer x and we are given some q queries, and for each query we are given a value p, and we have to find how many y's there exist such that GCD of xy to the power p is equals to LCM of xy. Now, first of all, tell me one thing. What is the relationship between GCD and LCM? You have some options like GCD is less than LCM. Like GCD of two numbers will be less than LCM. GCD of two numbers will be more than LCM. GCD of two numbers can be less than or equals to LCM, or GCD of two numbers will be more than or equals to LCM. What do you think is correct? Like everyone. Okay, someone is saying this thing is correct. What about others? Like only some. Like what about others? Will GC like think for a moment? Okay, some said this. Like when is this equal? When it's equal, when the two numbers on which you are taking the GCD and LCM are equal. If you take GCD of 5 and 5, or 7 or 9, or anything, 8 and 8, then GCD of 8 is actually equals to LCM of 8. So now what we like this comes like this is nothing but how is GCD calculated? What is GCD of AB? What is GCD of EB? GCD of AB is nothing but, let's say there are like in prime factorization there is some powers of A, and like let's say A can be written as, let's say, alpha, like in prime, like these are the prime factors, delta A1, A2, A3 and A4, and B is nothing but alpha to the power, like maybe some values like okay, first let me write down, then I'll explain. So it's possible that like you might think, is it like every like both of these numbers will have same prime factors? No, it is not 100% sure. But in that case, you can just replace, like let's say this thing is 2 into 3 to the power 2 into 5 to the power 6, and this thing is 2 to the power 2 into 7 to the power 1 into 5 to the power 1. So in this, alpha is this, beta is this, let's say gamma is this, and delta is this. So for this, you can assume that it's nothing but 7 to the power 0. And in this, you can assume that it's 3 to the power 0, right? So just make these powers 0. So that's how we can represent the two numbers like this. So GCD is actually GCD of AB is nothing but greatest common divisor. It should divide this also, this also, and it should be biggest. So it's nothing but alpha to the power minimum of A1 and B1 multiplied by beta to the power minimum of A2 and B2 multiplied by gamma to the power minimum of A3 and B3 multiplied by delta to the power minimum of A4 and B4. Right? This is actually the GCD. Yes, no. It should divide both. And what is LCM? Now, quickly, someone tell me what is LCM, how you can write LCM. Like same in terms of alpha, A1, B1, beta. It will be alpha to the power maximum of A1, B1. And like it will follow like this. Beta to the power maximum. Why maximum? Because LCM is lowest common multiple. So the common multiple will have at least alpha, like this prime factor, at least maximum of a1 and b1 times, like at maximum of these two, right? So same way I can write for beta, gamma, and delta also. So this is my LCM and this is my GCD. So what does this tell me? Like these two should be equal because these are prime factors, right? Like uh, power of this should be equals to this. Minimum of this should be equals to this thing. And actually, if I have something like a to the power b to the power c, what is this? Can someone tell me? How can I write? How can I write this down? Yes, perfect. A to the power b into c. I hope this is like known to everyone. If I have to first calculate a to the power b and then I have to calculate it to the power c. Okay. So this is a to the power b into c. So this is nothing but this gives me from these two equations, I need these to be equal GCD of power p. So power of p here comes, power of p comes here, power of p comes here. Like for each factor, you'll have power p. So you have minimum of a1, b1 to the power p equals to maximum, like not this to the power p, but you can have this p multiplied inside by the same thing, by this. So minimum of these two multiplied by p is equals to maximum of a1 comma b1. So now you can assume that first there are two cases. A1 is less than b1 or a2 is more than, like a1 is more than b1. So for these are the two cases, and in both cases the value is a1 is known to you, b1 will simply come out. If a1 is less than b1, then b1 is p times a1. If a1 is more than b1, then b1 is a1 divided by p. So this is for all those cases in which you have like these primes, these primes are occurring in A, right? If a prime doesn't occur in A, then in that case, like if there is a prime which is not occurring in A, then in that case, that prime cannot, like it's fixed. But if a prime is coming in A, you have two options. Like we have to find how many numbers of B like this exist, right? So I need to decide how many options do I have for alpha, how many options for beta, how many options for gamma, how many options for delta. So this is known to me, this thing is known to me. And what I can do, I just need to find how many options do I have for this thing, for individually for these. But I have found that, okay, for each number, I have two options. For each, like B1, I have two options. So if I have two options for B1, I have alpha to the power B1 also will have two options if B1 has two options. Why do B1 have two options? Because of this thing. This thing needs to be true, and either this will be less than this or this will be more than this. There is only one corner case scenario when P is equals to 1. What happens if P is equals to 1? Then in that case, B1 is like you don't have, these two will give you the same thing result. So in that case, you have one option. Otherwise, you have two options. So simply, what do we need to do? Just find which prime factors are in A, and your answer is you have two options for each of those primes. So 2 to the power x. Is it clear? Is it clear? Yes, no? Or is there any doubt? And by the way, you don't actually need to take modulo. I don't think you will require modulo because 10 to the power 9, like how many maximum number of primes, how many maximum number of unique primes you can have? You can have at max, I think, it will be less only. It will be around like not more than 15 or 17. If you multiply first 15 primes, I think the number will be close to 10 to the power 9 only. So that's why your answer will be around 2 to the power 15. So this number is not more than whatever the modular value is given. So that's why you don't actually require modulo. So let me show you the implementation. By the way, instead of trying on implementation, you should like understand the logic and then try to solve it. So this is the implementation in this. So primes can be calculated using sieve also, sieve method. Like everybody, like if you don't know sieve method, it's nothing but just mark the numbers, like first number as first number as not prime, then from that on one, like from start iterating from 2 onwards, and if you find that a number is prime, like 2 is a prime, then for every multiple mark the number as not prime, and for each prime number you'll mark all of its successors or all of its multiples at not as not prime. Or simply for this problem, what you can do, you can do the usual square root n complexity algorithm for finding the primes. So for every prime, like in this, I'm iterating through the primes, and then I'm checking if how many times, like if this prime divides this value is nothing but value is my x, and I'm checking how many times this divides my value is my x, and I'm checking how many times this prime divides my value. If it divides more than once, then I'm inserting it in a vector. Then for answering queries, first I take p in input. If p is 1, then you don't have to, like for every prime you don't have two like possibilities, you just have one possibility. So in that case, even if you like consider all those, it will be something like 1 to the power of number of primes. So in that case, 1 to the power something is 1 only, so simply print 1. But if p is more than 1, you have two possibilities. So for every prime in vector, just multiply the answer with 2 if it is divisible by p. Why it should be divisible by p? Because see, I'm writing here as this thing, ai by p. So b1 won't be a b1 needs to be an integer, right? If I'm writing how, like is can you write a number, some integer number, because a is an integer, can you write this as some prime to the power 3.5? No, right? So this thing needs to be an integer. So that's why b1, b2, b3, b4 needs to be an integer. So that's why this needs to be an integer. So p should divide how many times it's like this prime comes in a or x, right? So that's why if this prime divides this thing, then multiply your answer by 2. So this finally gives you 2 to the power some number of primes, and those primes are nothing but that occur in x and are divisible, like the number of times they come in x is divisible by p. Finally, you can print your answer. And if p is equals to 1, then you don't have two options for each. You have one option only. Is it clear? Yes, no? Okay, perfect. So that's it, yeah. Thanks for joining, and bye bye.